Hello out there, welcome to this tutorial on linear programming. In this video, we'll be looking at graphical method. So we start with problem 1. Problem 1. A shoemaker spends 2 hours to make a pair of shoes and 1 hour to make a pair of sandals. He works at most 10 hours per day. The cost of producing a pair of shoes is $80, while a pair of sandals is $60. He has at most $480 to spend. He makes $12 profit on a pair of shoes and $8 profit on a pair of sandals. Assuming he makes X pairs of shoes and Y pairs of sandals. A. Write down all the inequalities connecting X and Y. B. Show the required region which satisfies the inequalities in A. C. Find the value of X and of Y if the shoemaker wishes to maximize his profits. So in our solution, we are going to create a table starting from A. So in the first column, we'll be having the resources. The second column represents the pair of shoes, the pair of sandals, and the available resources. The first resources there is time. So we have time. The time for producing a pair of shoes is 2 hours. So we have 2 hours here. And the time for producing a pair of sandals is an hour, so we have it there. And he works at most 10 hours, so the available time for him per day is 10. Then the next resources is the cost of production, and the cost of producing a pair of shoes is $80, so we have $80 here, while a pair of sandals is $60, so we have 60. So what is the total amount of money available for the production? We have 480. Then we now talk of profit. The profit for the pair of shoes is 12. So we have 12 here. And for the pair of sandals, we have 8. We'll be calculating the available profit later. Then we use this table now to create our inequalities connecting X and Y. Since he's to make X pairs of shoes, the total time that will be taken will be X times 2. So we have it as 2X. And since he's making Y pairs of sandal and the time is an hour, so we are going to have it as 1 times Y, which is Y, so we have it as plus Y, and this is less than or equal to 10. So when you add the total time, he can spend exactly the 10 hours, he can spend less than that, but he cannot spend more than 10 hours in a day. So that is why we have it as 2x plus y less than or equal to 10. That is the first inequality. The second inequality will be number of pairs of sandals to be produced multiplied by the cost, which is going to give us 80x. In the same way, we are going to have it as y times 60, which is 60y. And that is going to be less than or equal to 480, since the total amount of money available for the production is $480. He either use all the $480 or less, but he cannot spend more than $480. And for your information, he may decide not to produce any shoe. So we are going to have it as x greater than or equal to 0. And in the same way, he may decide not to produce any pair of sandals. So we have it y greater than or equal to 0. Then we now have to create our objective function from the profit. So we are going to have that one as P, which is profit. If he produces 12 X pairs of sandals, he's going to have a profit of X times 12, which is going to give us 12X in the same way plus 8Y. This is the objective function, and these are the constraints. It is this constraint we are going to use to solve problem 1B. So we go to B. For B, we have to show the required region which satisfies the inequalities in A. So we go ahead and we are going to create table of values for two of these inequalities, which is this and this. And before then, we change this to equations. So we have 2x plus y is equal to 10. Then we now have our table. This is x, this is y. So we are going to use the intercept form to create the table. So when x is 0, so we have when x is 0, y is 10. So we have 10 here. And here when y is 0, when y is 0, we have 2x is equal to 10. Dividing both sides by 2, we have 5. And for the second inequality, we have 80x plus 60y is equal to 480. Then we have our table. This is x, this is y. When x is 0, this is gone. So we are going to have y to be 8. Also, when y is 0, this is gone. This is 80x is equal to 480, and our x is 6. So this one we know this is x greater than or equal to 0, y greater than or equal to 0. This is the y-axis and this is the x-axis. So we now go ahead to draw the graph. So we have our graph here. So for our graph, we are going to have our x-axis and this is our y-axis. This is the origin, and here we have 1, 2, 3, 4, 5, 6. We have to study the table of values to get our calibration correctly. And here we are going to have 2, 4, 6, 8, 10. And we start with the first table. When x is 0 is y-axis and y is 10, this is the point. We mark it out there. When y is 0 is the x-axis, so x is 5 there, we mark it out, then we join. And here we are going to join with our normal line. So we join from here to this place. And since this is less than or equal to, less than or equal to is the down part of this line. So we don't need the upper part. So we are going to shade the upper part of the line. So the required region here is downward. For the second table, when x is 0, y is 8. So it is on the y-axis. Y is 8 here. It is marked out. And when x is 6, y is 0. Or when y is 0, x is 6. So that is when y is 0, it is x-axis. X is 6 there, we mark it out. Then join. So we join. Again, we are shading the upper part since this is less than or equal to 480. Then for x greater than or equal to 0, that is the positive values of x. So it is going to be y-axis, and we shade that one appropriately. Then also for y greater than 0 is the x-axis, and we are interested in the positive part, which is the upper part, so we shade appropriately. And this is the required region. The unshaded part here is the required region. So we are done with B, then we go to C. So now at C, we have to find the value of x and of y if the shoemaker wishes to maximize his profits. From here, we are going to concentrate on the vertices of the required region. So the shape here is a quadrilateral, and this is the origin. We might not consider the origin as one of the vertices because it means no production. So we are considering this place, and this. We are not considering this place and this place because they are not within the required region. So we name this place A, this is B, and this is C. We get the coordinates of A, B, and C. For A, this is 0,8. We have 0,8 there. For B, this is 3,4. So we have a 3,4 here. And for C, we have a 5,0. Then we now put all this in the objective function. So we have a P of A, the profit that will be made at the point A. That is, if he doesn't produce any of the pair of shoes and he's producing 8 pairs of sandals, what will be the profit? So that's going to be 12 into 0 plus 8 into 0. That will give us $64 as gain. So at B now, he's going to produce 3 pairs of shoes and 4 pairs of sandals. So we need to know what profit he's going to make there. So we now have 12 into 3 plus 8 into 4. This is 36 plus 32, which gives 68. And at C, he's going to produce 5 pairs of shoes and no pair of sandals. So at that point, we have a 12 into 5 plus 8 into 0, and that will give us $60. And you can see now that he makes the highest possible profit at point B, where he will be producing 3 pairs of shoes and 4 pairs of sandals. So we conclude, to maximize profit, he makes 3 pairs of shoes and 4 pairs of sandals. And this is the end of solution to problem 1. We then go to problem 2. For problem 2, a shop owner makes 2 kinds of drinks, A and B, daily. A bottle of A is made up of 10 centiliters of mango juice and 10 centiliters of orange juice, while a bottle of B is made up of 20 centiliters of mango juice and 10 centiliters of orange juice. There are at most 140 centiliters of mango juice and 100 centiliters of orange juice available. The minimum order she has each day are 2 bottles of A and 2 bottles of B. She makes profit of 150 naira on A and 200 naira on B. Assuming that she makes X bottles of A and Y bottles of B. A. Write down all the inequalities connecting X and Y. B. Show the required region which satisfies the inequalities in A. C. How many bottles each of the drinks will yield the highest possible profits? So we start with A, and again we are creating a table, and this is the resources, the number of bottles for drink A and the number of bottles for drink B, and this is the available resources. So the first resources there is the mango juice, the orange juice, and we have our profit. For drink A, it is made up of 10 centiliter of mango juice, so we have 10 here. Then how many mango juice is required by drink B? 20 centiliters of mango juice, so we have 20 here, and the total amount of mango juice available is 140, so we have 140. For orange juice, A requires 10 centiliters, we have 10 centiliters here, and for B it also requires 10 centiliters, like B is made up of 10 centiliter of orange juice, so we have 10 here, and the total centiliters of orange juice available is 100, so we have it 100. He makes 150 from A, so 150, and 200 naira from B, we have 200 naira. So forming our inequalities here, we are going to have 10 times x, which is 10x, then 20 times y, which is 20y, is less than or equal to 140. Then for the second inequality, we have a 10x plus 10y is less than or equal to 100. The minimum orders she has each day are 2 bottles of A and 2 bottles of B. So which means she must produce at least 2 bottles of A, which means x is greater than or equal to 2. She cannot produce none. She must produce, if she must produce, she must produce at least 2. The same thing for B. So y is greater than or equal to 2. Then for our objective function, we are going to have 150x plus 200y. And this is the objective function, and these are the constraints. It is these constraints we are going to use to draw our graph. And that will take us to B part of the problem. For B, I am going to change this to equation, the first inequality. So I have it as 10x plus 20y is equal to 140. I create the table. So this is x and this is y. When x is 0, y is 7. And when y is 0, x is 14. Then for the second inequality, I have a 10x plus 10y is equal to 100. And our table is here. This is x, this is y. When x is 0, y is 10. And also when y is 0, when y is 0, x is also 10. So we'll be using this to draw our graph. So we go ahead to draw the graph. So here is our graph. As usual, we have our x-axis and our y-axis. So here is the origin. This is going to give us a 2, 4, 6, 8, 10, 12, and 14. That is 2 centimeters representing 2 units. The same thing on the y-axis, 2, 4, 6, 8, and 10. And for the first table, when x is 0, y is 7. This is when x is 0, y is 7. This is 7 here. So we mark it out. When y is 0, x is 14. This is when y is 0, x is 14 here. It is marked out. Then we join the 2 points. As usual, we are using less than or equal to, which is the down part that will be required. So we shade the upper part. So the part shaded is not required. For the second table, when x is 0, y is 10. This is the point here. And also when y is 0, x is 10. So this is the second point. Then we join with the bold line. We are shading the upper part because the down part is required since it is less than or equal to. So we are done with that. And remember, x is greater than or equal to 2. So this is the line. So we shade. And that is that. Y greater than or equal to 2. So we have to find the line y equal to 2. This is the line y equal to 2. We are shading the down part since it is greater than. We need the upper part. So we shade the down part. So this is the required region. So we are done with B and we'll be going to C. For C, we need the vertices of the required region. So we have this point A, we have this point B, this is point C, and this D. So the coordinate of A is 2, 2. The coordinate of B is 8, 2. The coordinate of C is 6, 4. So we have 6, 4. And the coordinate of D is going to be 2, 6. 2, 6. Then we are to find the number of bottles of each of the drinks that will yield the highest possible profit. So we are going to be substituting all these into the objective function. So we go ahead to do that. First, we start with A. We find P of A. That's 150 into 2 plus 200 into 2, which gives 700. This is 300 plus 400. And for P of B, we have 150 into 8 plus 200 into 2. This is going to give us 1600. And for P of C, we have 150 into 6 plus 200 into 4, and that will give us 1700. For P of D, we have 150 into 2 plus 200 into 6, and that will give 1500. And you can see the maximum profit here is at P of C. So we now conclude, to make highest possible profit, she makes 6 bottles of A and 4 bottles of B. And that is the end of solution to problem 2. This is the highest we can take in this tutorial. Thank you for watching this video. Remember to like and share the video. If you have any reservation, the comment section is open for your comments. Until we meet again, goodbye.